Okay, we're going to look at the answers to the Chapter 5 test, which I gave as a review this week. And so let's go ahead and start with the first ones, where we have negative exponents and positive exponents. Just a reminder, if you have like a negative exponent, what that means is you want to put it into the other part of the fraction. So right now this is on the top. We don't write it over 1, but it's there. And it moves to the bottom and becomes positive. If it's on the bottom, so you have like a 1 or something up here, and you have a negative exponent, then that means it wants to move to the top. Remember, like, it's unhappy. And now it's happy because it's in the correct part of the fraction. And the other thing we need to remember is the 0 exponent. Anything to the 0 power will be 1. And then there's all these other rules that we reviewed that you should know, like n to the a exponent times n to the b exponent. If these are the same and you're multiplying them, we can add these exponents. If you have a power to a power, it's like this, you would multiply, so a times b. If you have division going on, you could subtract, so it would be a minus b, b, and there's a couple of other rules, but okay, so let's go ahead and take a look at number 1. So we have a to the b, or a to the 5th, b to the negative 7, c to the 0. The first thing I see is this c to the 0. That's a 1. And when you multiply by 1, it doesn't do anything. So it's kind of like this just can go away. Then I see this b to the negative 7th. It's not happy, it's negative, so it wants to go into the bottom. So I'm going to have a b to the 7th underneath an a to the 5th. Our second one here, notice that we have a 0.93 and a 0.93. That means we have the same base, so we have to take these exponents and add them. So we're going to get 0.93, and then if you add 6 plus negative 8, you get negative 2. Now we can't write it like that. It's a negative exponent, and this says use positive exponents, so that's going to be 1 over 0.93 to the positive 2 power. Now since 0.93 is a number, we can actually take a calculator and square it, and we get 0.8649. Where did my pen go? There we go. So this is 1 divided by 0.8649, which we can figure out what that is. We can divide 1 by that number, and it's approximately 1.15. Okay, on to number 3. We've got q squared and a q cubed. Those can combine. So you can use the subtraction rule where you're doing 3 minus 2 because the q's are the same. But sometimes I just think of it as, okay, there's 2 q's down here, 3 q's up here. So 2 q's will cancel with 2 q's, and there will be 1 q left over. You can do that. That's allowed. If that makes more sense to you, then do that. Okay, I also have a negative exponent here. I have r to the negative 6. So I'm going to move him to the top. Alright, so let's write what we've done here. No, I didn't do anything with the p to the 3. It's still there. I now only have one. All these q's are gone except I have one leftover q at the top. And I have now r to the negative 6th is r to the positive 6th on the top. And there's nothing left in the denominator. So you could write it over 1, but you don't even have to do that. And that's it. That's all you need to do. There's nothing else I can do. Alright. Here we've got some stuff inside parentheses being taken to the negative 3rd power. So that negative 3rd power this is a power to a power problem. We're going to multiply these exponents. So we're going to multiply the 3 times negative 3, the negative 5 times negative 3, and the negative 1 times negative 3. And that's going to give me m to the negative 9th, n to the positive 15th, and then, yeah, there's another m here, to the positive 3rd. So I just noticed that there was actually 2 common letters here. We've got an m and an m. I could have done some stuff with those inside the parentheses first, but the fact that I didn't, and I'm going to deal with them now, is fine. Okay, so now because I have common m's here, I can take these two exponents and I can add them. So that's going to give me m to the -6th, and then I have n to the 15th. Again, I can't leave negative exponents, so this guy right here, he needs to go to the denominator, and that's going to take my whole answer and be n to the 15th on top, m to the 6th on the bottom. Okay, let's look at number 5. Let me clear some space here. So we've got some common things in here. We've got x's here and here, and y's here and here. Now, I'm not a big fan of the subtraction rule, this one. I mean, you can always use it, but I think it's a bit more difficult. I like to deal with negative exponents first if I see them. So I have a negative exponent there and a negative exponent there. So I'm going to take this x to the -3, and I'm going to move it to the top, so it's now x to the +3 up here, times the x to the 4 that was already there. So here's my fraction bar. Okay, then my y's, I'm going to take this y to the -2. He's on the top. He's not happy. Move him down. So y to the +2. Remember, when you move it, the sign changes. And then y to the 5th was down there also. Okay, so then that's x to the 7th over y to the 7th. And now I haven't done anything with this -1 exponent. When I deal with a -1 exponent, I'm going to have to do some multiplication. I'm doing -1 times 7 and 7, which is going to give me x to the -7th over y to the -7th. So basically I just made both those things unhappy. So now they want to switch. So I'm going to switch them. This one's going to become y to the 7th and x to the 7th, and now there's my final answer. I'm going to do number 6 down here. So we have u to the -5th v squared times a negative u cubed v to the -2 being taken to the 4th power. First thing I have to deal with is this 4. He needs to multiply by the 3 and the -2. So when we do that, and actually one more thing, so we're taking u to the 3rd to the 4th power and v to the -2 to the 4th power. That's what the multiplying rule is. But you see this negative sign out here? It's like there's a -1. So he needs to be taken to the 4th power also. Okay, so first thing, I'm just going to write this u to the -5th and v squared out in front. And then I'm going to have a -1 to the 4th power. All of this is multiplying. And then I have u to the 12th when I do 3 times 4, and v to the -8th when I do -2 times 4. So let's talk about this -1 to the 4th power. -1 to the 4th power means -1 times itself 4 times. Now -1 times itself just once will become a +1. These negative signs cancel. And that's just going to happen again. So here I get another +1. And +1 times +1 is 1. So this is just 1. And remember, when you multiply by 1, it doesn't do anything. So we can kind of just ignore it. Okay, let's look at the u's. We have u to the -5th and u to the 12th. We are going to turn that into u to the 7th by adding, because we're multiplying these together. And then I have v squared and v to the -8th. So I'm going to add those exponents, and that gives me v to the -6th. Negative exponent wants to go to the bottom. So I have u to the 7th, v to the 6th. There's your answer. Okay, for number 7, it says which expression has the greatest value when z is equal to 1/2. So they're all z's. So what you want to do is you want to combine them first. So this is z to the -2, which is going to be 1 over z squared. Now since z is 1/2, what I'm doing is taking 1/2, squaring it, divided by 2, which is 1 divided by 1/4. And if you think about it, how many fourths go into 1? It's the same as like how many quarters go into a dollar. It's 4. Okay, now this one, I've got power to a power rule, so that's z to the positive 4th, z to the negative 10th, which is z to the negative 6th, which is 1 over z to the 6th. So that's going to be 1 over 1/2 to the 6th, which is 1 over 1, let's see, 2 to the 6th is 64. This actually gives you 64. So A is out of the running. B is looking good. Okay, this is going to be z to the 15th, which is 1/2 to the 15th power. That is a very small number. That is, let's see, that's going to be, let's get my calculator to do it right. Really, 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 really tiny. That's basically 2 to the 15th, which over underneath 1, which is 32,768. That's 1 divided by that. That is really small. Okay, so C is not it. And now let's do D. Okay, we're going to multiply. We'll have this negative out in front. And then that's going to be z to the negative 6th, z to the 12th, which is z to the 6th negative. Well, this is going to be a negative number, so that's already too small. I mean, if I plug in 1/2, it's not it. The answer is B. Okay, we skipped 8, and on number 9, I don't want you to worry about part B. We're just going to look at part A. It says a population of 2,000 fish increases at an annual rate of 7.5%. Okay, so we're using this formula. X or T, doesn't matter. So A is your initial amount, which in our case is 2,000 fish. That's what we're starting with. R is your percentage rate of increase, because it's increasing. And we have to change it to a decimal. So at 7.5% as a decimal, move the decimal place over twice, you get 0.075. Now, if this was decreasing, we'd use a subtraction sign right there. And then how many fish will there be in 10 years? That's your T, or I guess X. I can't remember which one. I go back and forth. And Y is sort of just your output, your answer. So I have 2,000 times 1 plus 0.075 to the 10th power. Okay, so you're going to need a calculator on this. First, we're going to add these two. You get 1.075. And then I have to take this number to the 10th power. So that's where you're going to need a calculator. And so that number is 2.06103 in the calculator. I'm just going to leave it in the calculator, and then in my calculator I'm just going to write or times 2,000. Alright, and we get about how many fish we have in 10 years, which is 4,122 fish. Now there's some decimals behind here, but I'm rounding it to represent a number of fish. Okay, evaluate each function for -1, 1, and 2. All they're asking you to do is plug in these numbers. Okay, so find f of -1. That means plug in -1. So 4 times 7, and then where x is, I'm putting -1. Okay, that negative exponent means it's going to go to the denominator. So this is 4 over 7 to the first, which is just 4 over 7, and we can leave it that way. Alright, now let's plug in 1. Okay, that's just 4 times 7. So when I plug in +1, I get 28. Okay, let's do 2. So now I'm going to plug in 2. And so that's going to be 4 times 49, which is 160 plus 196. Okay, so my three answers are 4/7, 28, and 196. Okay, so that's pretty much the procedure for all of these. So I'm going to do the rest of them a lot quicker, okay? And don't worry about if it says f of x or y or h of x, they all kind of mean the same thing. Okay, so first one, 2/3 times 6 to the negative 1 would be 2/3 times 1/6, which would be, can do some cross canceling here, 1/9 is our first one. Then 2/3 times 6 to the 1 is just 2/3 times 6. Do some cross canceling, that's 4. 2/3 times 6 squared would be 2/3 times 36. The 3 goes into the 36 12 times. That gives you 24. So I completed the last two here. They're pretty straightforward. The only thing I would want to point out is this one right here, number 13, where we have 4/5 to the negative 1 power. When you take a fraction to a negative 1 power, the shortcut is to just flip it over. So you get 5/4. Okay? Pause the video if you need to check these answers. Alright, let's keep going on. Alright, so we have to decide if each sequence is a geometric sequence. Geometric sequence is when you are multiplying by an r, a number that we call the common ratio each time. Okay, so from 15 to 45, that's times 3. But from 45 to 75, that's not times 3. This one actually looks like it's adding 30. Now, adding is cool and all, but that's not geometric. That's arithmetic. So this one's not geometric. Okay? 15, well, from 3 to negative 9, we're multiplying by negative 3. Let's see if that works out again. Times negative 3. Yep. Times negative 3. Yep, it looks good. These check out. So this one's is, yes, it is geometric. And the common ratio r is negative 3. It's what you're multiplying by each time. Now here, it looks like we're dividing. It looks like we're dividing by 10. Now, that does mean it's geometric, but we can't think of it as dividing. We need to think of it as what we're multiplying by. And what we're multiplying by is 1/10th. Remember, if you're dividing by a number n, you're multiplying by 1/n. It's the reciprocal. So if I multiply each of these by 1/10th, it will basically be like dividing by 10. So this is yes, and r is equal to 1/10th. Or as a decimal, you can write that as 0.1. Same thing. Okay, simplifying. Simplifying the radical expressions. Whoa. We've been doing this more recently, so hopefully this is fresher in your brain. We're looking for a perfect square that goes into 150, and that number is 25. Right? Remember perfect squares like 4, 9, 16, 25. The reason we want 25 is because when we take the square root of it, it becomes a 5. And it doesn't have a square root symbol around it anymore because we took the square root of it. And so 25 times 6 is 150. So this is going to be 5 square root of 6, and that's all we do. So here we're going to do the 45. 45 is 9 times 5, and that will square root of 9. That's your perfect square. The square root of 9 is 3. Okay, but now we have to deal with this n to the 5th. N to the 5th, you remember we look at how many squares are in there. There's 1, 2, so that's 4 n's, and then 1 left over n. So each time you have an n squared, it comes out of the square root as an n. So I'm going to get an n here, an n here, so I'm going to have an n squared on the outside. And then this one stays on the inside. So this is your final answer right here. Okay, I did number 19. It's pretty much the same thing. You can go ahead and look at the different numbers. It's very, very similar to number 18. Okay, let's talk about number 20. These get a little bit more overwhelming when we're multiplying. You have to look at what is on the outside. Those are just regular numbers that need to multiply. So negative 8 times 12 will give you negative 4. Okay, now let's multiply the square roots. Now within these square roots we have numbers and variables. The numbers need to multiply, but I'm going to give you a little hint. I don't actually want to multiply these. It's going to be easier if I keep them separate. I'll show you why in a second. And then a squared times a will be a cubed. So we need to simplify this. Now, it's going to be easier to keep these separate. We can kind of simplify two numbers instead of multiplying them together to get a bigger number. Like if I do the square root of 54, what goes into 54? Like what's the perfect square? That would be 9. It's 9 times 6. 9, the square root of 9 is 3. And so I know there's a 3 that's going to come out. Okay. Then if I do the same thing with the 36, well, the square root of 36 is just 6. It is a square root. Right? It's 6 squared. So nothing gets stayed beside. So what comes out here is a 3. What stays, and a 6. And what stays in is this square root of 6. Okay, so I have a negative 4 that was already there. I'm taking out a 3 from here. I'm taking out a 6 from here. I know inside left over there's going to be a 6. And now the last thing I have to deal with here are the a's. I have a cubed. The square root of a cubed is the square root of a squared times the square root of a. There's 1 that can come out. So I'm going to take out an a, and then there's going to be 1 left over. All I have to do now is figure out what negative 4 times 3 times 6 is. That's negative 72, and then the a times the square root of 6a. There's our final answer. Okay, I did 21 and 22. So you can pause the video if you need to. You can look at my work for how this is done, and these are the answers. Okay. Graphing the functions. The steps that I gave you was I gave you some major points that are always used with these when you have y equals a times b to the x. Now first of all, look at the b values, 3 and 0.5. If it's greater than 1, if the b is greater than 1, then it's growth, which means your graph is going to look something like this. If its b is between 0 and 1, like this one is, it's a half, it's going to be decay, which means it's going to start high and go low. But each of these do not cross into the negatives. It doesn't even get to 0. Right? We talked about that in class. Okay. So let's look at how we actually graph it. There was 2 essential points that I told you to use. If you plug in 0, you just get out a. And if you plug in 1, you get the product of a times b. And those are the 2 points that I use. So here, if I plug in 0, I'm going to get a third, because this would turn into a 1. And 1 times 1/3 will just be 1/3. Okay, now let's say I plug in 1. Then that's going to be 3, or 1/3 times 3, which would be 1. So I get 1, 1. So I'm just going to sketch a graph. It doesn't have to be perfect. Alright, so we have the point 1, 1. Put a dot. That's this one. And the point 0, 1/3. So over 0, up a third. That's this one. I'm just estimating. And remember what the shape looks like. It doesn't cross the x-axis. Oh, my 1/3's in there somewhere. And then I go up through this point. And that's it. Alright. Then this one would be over 0 up a, which is 1, and then over 1 up a times b, which is 1 times a half, which is a half, or 0.5. So over 0 up 1, here's 1, over 1 up a half, and you can see so it's falling. Using this pen is a little hard to get the graph look right. It should be going more straight. But you could just sketch it. Okay, 27. Well, we want to think about this thing here as 2 to what power? That would be the negative 2 power. 2 to the negative 2 power is 1 over 2 to the second power, which is 1 over 4. So I know that this thing equals 2 to the negative 2 power. So take this and set it equal to negative 2. Add 2 to both sides, and x is 0. Okay, here I'm going to subtract 5 first. I could divide by this negative 1. And then I get 3 to the x is equal to 27. And then I'm like, oh, okay, x is 3, because 3 to the third power is 27. Write a geometric sequence. So let's just say 10, 20, 40, 80. So I'm multiplying times 2, so that's r. And my first term, a1, is 10. So write an explicit and recursive formulas for your sequence. So you can make up any sequence you want. So look up for your formulas. The explicit is going to be an equals a1 times r in parentheses to the n minus 1. So all I have to do is plug in a1, 10 here, and 2, which is my r, here. So that would be 10 times 2 to the n minus 1, and that's where I leave it. I'm done. Recursive, that's an equals a to the n minus 1 times r, semicolon, we also have to include a1. Okay, so again, a1, just whatever that is, and r. So let's plug it in. So that would be, so it's two parts. So an equals an minus 1 times 2. And a1 is 10. And that's the recursive formula. Okay, number 30. In the exponential decay function, y is equal to 3 times 0.25 to the x. Is there a value of x that will make y less than 0? Explain. We talked about this in class. That less than 0 is math terminology for negative. It's another way of saying negative. And we're saying, is there any way I can make an exponent make this negative? And the answer is no. Negative exponents do not make negative numbers. Negative exponents move things to the denominator, but they don't change the sign of a number. So if everything here is positive, there's no way to make this a negative number. Okay, number 31, last one. The number of deer living in a state park is given by the function f of x is equal to 200 times 1.5 to the x power. And the number of moose living in the same park is given by the function g of x, which is 150 times 2 to the x, where x is the time from now in years. Find an expression for the total number of moose and deer. So this is, when we're talking about total, we're talking about adding functions. So we're going to take f and g of x and add them. So that means we're going to take 200 times 1.5 to the x and add 150 times 2 to the x. Now, these are not like terms. These are different. There's nothing I can do to add them. So I'm going to leave it like this. But then for the second part it says, after 2 years, what fraction of the animals will be deer? Okay, well, let's find out how many animals in total will be deer. So f plus g of 2. So I'm going to plug in 2. Exponents first. That one's 4 times 150. Now 1.5 squared, I'm going to have to use a calculator. And that's 2.25 times 200. So I'll have to multiply. Okay, so that's 450. And that's going to be 600. So that's 1,050 animals. The question is, what fraction of the animals will be deer? Well, deer was f of x. So deer is 450. That's deer. This was moose. So we're looking at 450 out of the total, which is 1,050. So we can reduce this. We can divide by 10. That would get rid of the zeros. We can divide by 5. That'd be 9. Divide 105 by 5. That would be 21. I can reduce these by 3. And that would be 3 over 7. So 3/7 of the total animals would be deer. Okay, that's it.